Imagine you have pre-trained skills such as grasping novel objects or placing held ones into various types of containers. Usually, these skills do not take collision avoidance into account because they are trained in clutter-free environments. Naively deploying such robotic skills to cluttered environments can lead to undesired collisions with the surrounding obstacles and drastic deterioration of the overall performance. In this paper, we introduce a method which enables these skills to now be deployed in cluttered environments whilst maintaining the high performance of the original skills. Our method consists of 3 steps and does not require changing already acquired skills in any way. The robot first observes the scene and predicts where it should start a skill to complete the task and not collide with the surrounding obstacles. It then reaches this configuration using a motion planner. And finally, the skill is executed, completing the task. In this illustration, putting the held yellow bag into a wide ball. Our method relies on the ability to find robot configurations from which already acquired skills are likely to succeed. We achieve this using a novel affordance model that predicts if a robot would complete the task without colliding with obstacles if started from a specific configuration. We train this affordance model using a dataset containing examples of good and bad configurations to start specific skill from. During test time, we optimize this model to find an optimal starting configuration. We extensively evaluated our method in 6 types of randomized simulated environments, each with inherently different structures and increasing complexity. We did so for grasping and placing skills that were trained in a clutter-free tabletop environment. Here, you can see our method in action in previously discussed simulated environments for both grasping and placing skills. The robot first reorientates itself into predicted starting configurations from which already acquired skills are executed. We trained our method solely in simulated scenes. However, we are able to deploy it directly on the real robot. Using a real soy robot, we tested our approach in 3 different types of tabletop environments with increasing levels of clutter. For the remainder of this video, we now show our method's performance in real-world environments for both grasping and placing skills, together with some failure cases.